Yeah, so this graph, you got the right solution, 1, 2, and 3, right? Intersection, so 3 solutions, it's fine. However, your graph is a bit wrong. You see, the x-intercept here, you have to be very careful, okay? The x-intercept of the cosine graph is actually 3 pi over 2 in this case. It's 3 pi over 4, sorry. Right, because we divided by 2. And if you type in a calculator 3 pi over 4, it's actually smaller than the x-intercept of this graph, which is x minus 2, intercept at 2. Okay? Like, this is the slightly better graph. The 3 pi over 4 is here, then the x equal to 2 is slightly towards the right. Okay? Does it make sense?
Yep.
Here is 2. There is 3 pi over 4. So you have to adjust your graph a little bit. Yeah, but your number of solutions is still correct. So okay, nothing to talk about. Okay, moving on. Next one. This one is wrong. You question 6, you're trying to draw cosine graph. What do you draw here?
Oh.
Should go downwards, right? Down, down, up, up. Remember, cosine, down, down, up, up. Sine is up, down, down, up. Okay, so yeah, let's just redraw this. Try to use the exact value, just put square root 3. Okay, let's just quickly sketch this. So what do I want? 3 sine theta and square root 3 cos theta, is it? Okay. This is from 0 to 360, but they only request for 0 up to 90 degrees, right? So I only need the first half. So I don't even need so much. I just need the first branch until here. This is 90 degrees. This one is theta, not x. Sorry, this one should be theta. I forgot to mention. I always use x in my questions, but actually it can also be any length. You must follow the question. If they use theta, you draw a theta axis. Then for the y-axis is still y. That is for 3 sine theta. Maximum at 3. How about square root 3? Slightly below at 1.7. So just put down square root 3. Cosine graph this time, so you must go down, down, up, up, right? Down, down, up, up. But you only need up to 90 degrees, so just go down until you hit here. Okay, so you realize they actually have a point of intersection over there. What's the coordinates of that point of intersection? We need to solve the question, solve the equation simultaneously. So 3 sine theta equals to square root 3 cos theta. Then how to solve this? Well, you just need to bring the cosine over, bring the 3 over. Oh, sorry. Yeah, then square root 3 over 3, and this is just tangent theta, right? But square root 3 over 3, I hope you remember. I think it's 60 degrees, this one. Is it 60? Yeah, never mind, just use a calculator. Square root 3 over 3. And then you get, no, it's not 60, it's 30 degrees. I remember wrongly. Okay, so that's our solution. We don't need to care about the other angle. I know usually positive, you will have 2 answers, right? From 0 to 360. ASTC. Expecting answers in quadrant 1 and quadrant 3, but don't need the quadrant 3 answer because we are only concerned with up to 90 degrees. Only quadrant 1. 0 to 90 degrees is quadrant 1. So the answer to this question mark over here is 30 degrees. And how to answer the question now? You want 3 sine theta to be more than or equals? What do you think is the updated answer? Three sine theta more than equals. What's the correct answer? Is it still 0 to 90 degrees? The answer over? No. You want the purple to be above.
Theta more than 30, less than 90.
Yeah. Can it be equal?
No.
Can we have equal? Why cannot? Why can?
Wait, the question have equal.
Yeah, the question has equal, right? So, is it right? There's an equal. So you should also include the equal. You can allow for equality. All right, and a nicer way to present this is to write it from small to big. Okay, so you can see it goes from here until here, right? 30, then 90. Then your theta is sandwiched in between. So here's another way that you could present this. It will be 30 degrees less than equals to theta less than equals to 90 degrees. That's your answer. Can? Clear? Can I move on? Okay, can yeah, just be careful of drawing the correct graph. Next one, okay, basic for this question, we ask you to find a point of intersection of two graphs, right? It's just simultaneous equation. You just need to equate the y's together. I mean, solve these two equations, equation 1, equation 2 simultaneously. Usually you do a substitution. Y equals to y, so you can just equate the 1/4 plus sine 2x and half cos x, which is exactly what you did, right? Sure. Yeah, then blah, 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 you solve it so that you eventually get it in the same format as this one. 2 times cosine x minus something times sine 2x equals to 1. The something is k. And you can clearly see, right? The k over here became a 4. So the answer to the question is k equal to 4. Is that okay? Okay, good. Yeah. Then part 2, state number of solutions. Just look at the number of point of intersection. 1, 2, 3, 4. So it's 4. Right? You just have to draw the graph and find number of point of intersections. Okay? This one? Is it clear?
Yeah.
Yes, okay, then I move on already. Okay, next. Yeah, the rest is this is fine. Nothing to talk about. Just a personal preference for me. I like to add the 360 first while it would still a 2x. Then after that I divide by 2. Okay. You just add 180 after dividing also okay. Just need to make sure you don't add 360. Next.
Okay.
Question 9. Also nothing wrong. Okay, then it's fine. This question, this worksheet is done. Okay, graph sketching over. Let's go through the Swiss cottage paper.
Wait, actually, I have a question. Because
Yes.
the worksheet you sent me, right, there's more than 9 questions. And I think you actually went through like question 10 and 11 before. But when I tried to do it again, I already forgot.
Oh, okay. Question 10 and 11, is it? Sorry.
I think so. Yeah, I think so.
Okay, let me go and see the question. Oh, 10 and 11, theme park question, is it? Theme park and Ferris wheel.
Yeah, I think you went through with me before, but I forgot.
Okay, then let me just open up that worksheet. Not this one. This guy. Where is it? Actually, I didn't went through. I went through a different question here. I went through a question 16 from a different question. Question 11 is different from the one I went through. I think the question 10 is the one that I already went through. I'll start with that. If I can find the working. Where's my question 10? I cannot find. Never mind. I'll just redo it. Okay.
Okay.
I'll do it under the your question 4 to question 9. Okay, let's. Let me take a screenshot of the question first. Question 10 and 11. Okay, question 10 here. A theme park is building a new roller coaster. Part of the track of the roller coaster can be modeled by h equals to 15 sine theta plus 8 cos theta plus 20, where h meters is the height above the ground level, and theta goes in between 0 to 360 degrees. In between 0 to 360 degrees, then the equation for h can also be identically rewritten in as the following format. H equals to 17 times the sine of theta, but you add on a very weird angle known as tangent inverse 8/15. And then you close the bracket, then plus 20. Now, in the future, I'm going to teach you how to convert it from this to this. The original question actually requested for you to prove that it is this format. But I decided to change the question. I'll just state it. I'll give it to you for free. Free gift. Convert like this for you already. You can take it as it is. Then after that, the theme park, they tell you is near an airbase. Then there's regulations forbidding buildings from exceeding a height of 50 meters. Or theme parks, roller coasters as well. It's considered as part of buildings. Now explain if this design will exceed the stipulated height limit. So height cannot exceed 50 meters. In other words, you want your H to be less than 50 meters. Right? This is what you want. Okay, sorry. Actually, not exactly. It's more like H can be related to 50. If H is less than 50, then we are safe. We pass the regulations. Then if H is exactly equal to 50, here they said exceeding a height, right? So I think it's still under safe. Then we can combine into less than or equals. But you're getting it on the boundary, so practically not very smart. You don't want to be on the boundary, not so safe. Have some clearance. Okay, so if it's more than 50, then it's not safe. Or rather you do not pass. You do not pass. Do not pass the regulations. Okay, then with this in mind, we have to check our formula for H, the height. What's the maximum value of H here? Sine is always in between what two values?
1 and 0. I mean,
No,
1 and
zero.
-1.
-1 and +1. So the maximum value of sine is actually just +1, right? So that means this is equal to 17 times +1 plus 20. Let's calculate that. Oh, it's 37. So which one?
Oh,
which
so
option?
no.
So yeah, it's safe. Safe. Pass.
What?
Will
so
they exceed? Oh,
easy?
not exceed. That's all.
What? So easy. I thought it would be very like. Okay.
No, very easy. This one is just like the yeah, that's all there is to it. It's just 2 marks. Okay.
Okay. I recall you. Then I recall you. Yeah.
No, very easy question. Okay, don't worry too much about it. The difficult part is in converting from this format into that format, which you will eventually learn later. R formula. Okay, moving on to question 11. Let's go. Let me. Now this is a nice roller coaster question. Draw a nice little sorry, not roller coaster, Ferris wheel. Nice little Ferris wheel for you to see. Okay, let's zoom in to read the question. The figure, it shows a Ferris wheel of diameter 158 meters and whose center is 88 meters above the ground. The wheel takes 36 minutes to make one complete revolution. A boy is currently at point P. So it's like along a horizontal line that passes through the center of the Ferris wheel. 88 meters above the ground. So if it's 88 meters here, of course, it's also 88 meters there, a rectangle shape. Then given that the equation y equals to a plus b sine 10t degrees, where y is the height. Let me just copy down the equation first. Y is the height in meters of the boy's position above the ground, and t is the time in minutes after passing P. Find the value of A and of B. Do you understand what this equation is referring to? What is Y again? Y is the
height.
After T minutes from point P. So let's say, for example, we plot a few points. We just draw a table just to make sure we understand.
Won't A be 88?
Yes, correct. A is 88. Okay, you get it already. Yes, if T is 0, the Y is really just A plus B times sine of 10 times 0 is 0, right? Sine 0 is also 0, right? Then therefore a plus 0 is just a, which means when t equals to 0, the y equals to a. And when t equals to 0, the boy is still at point P and he's 88 meters above. So that's why a equals to 88. Okay? The initial height before you start moving away from point P. And then later it starts to rotate anti-clockwise as time passes. And the height of the boy, if you can imagine like a eyeball here staring at the boy, it's either moving upwards or moving downwards, right? You can imagine you turn a circle around and around and around, and then you have a person standing at the side looking. If you're looking directly towards the left, right, you'll only see a single point that's bobbing up and down, going up, going down. Right, this one is called simple harmonic motion, I think. Or it's a topic in physics, but you probably eventually need to learn this. I did not have to learn this because I study biology. But it's okay. You can go read up if you're interested. Anyways, we found out our A to be 88 already. Then we carry on. How to find B then? B is the
amplitude.
So it means your how far away you go up and above above and below the midline, right? So in this case, I think you can see the midline is here. You're going maximum and minimum to the maximum to the minimum. So oh, 158. Where do you get 158 from?
I said diameter is 158.
Okay, good. So that means that this guy here must be the radius. So divide by 2 and 79. Okay. Then that means amplitude is just 79. Is it okay?
Oh, okay.
Yeah.
It is.
Yes. Yes. How far away you travel above and below the midline. That's your amplitude. And the maximum height the boy can be above from the reference point P is 79 meters, the radius, or below 79 by 79. Okay. Yeah, so that's all for part 1. Then part 2, let's see. So part 2, hand sketch the graph. Easy. Just need to follow the graph. I mean, let me read the question again. Sketch the graph of y equals a plus b sine 10 t degrees for 0 degrees less than equal t less than equal to 180 degrees. So only until 180 degrees. So typically, let's say if it's 360, then we will have a midline, right? A midline, maybe I'll use my dotted line function.
80.
Ignoring the 88, there's a 79, right? So it's plus 79 above and then 79 below. And up, down, down, up. This is from 0 to 360 degrees. But since this is plus 88, so that means this must be 88. And since we know the amplitude is 79, you plus 79 and minus 79 from the 88, which means the maximum value here is 88 plus 79, which is 167, or 88 minus 79, which is 9. Okay? Plus the amplitude minus the amplitude. Then after that, you fill in the x-axis. You draw the graph first, then you draw x-axis later. Okay? Oh, sorry, not x-axis, it's t-axis. Right? That's if it is sine, that is if it is 88 plus 79 sine 1t. Right? But that, and up to 360, but that is not true. That is not true. We are dealing with 10t. 10t. So that means that how many copies of the graph do we expect to see?
10.
10, right? Then that's a bit difficult to draw. Let me think a little bit. They can't expect us to draw 10 copies of it. Did I interpret wrongly? It takes 36 minutes to make one complete revolution. T is the time in minutes. Oh, really? Okay, they really expect us to draw a few times. 36 minutes for one revolution. Then here they want 0t less than equal t less than equal 180 degrees. So we need a maximum t to be 180 minutes. How do you go from 36 to 180? You need to times 5, right? So 5 revolutions. So how come 5 revolution? I thought 10t, then it must be 10 cycles.
Plus
The
180.
10 yes, correct. It's only until 180. This 10 only applies if it's from 0 to 360 degrees. Then you need to draw 10 copies. But here we are only required to draw up to 180 degrees. So don't need to draw so many copies. Just 5 copies will do. Wow. Let me think. How do I split this up evenly into 5 copies? Let's see. Just try to make it accurate. I think 1, 2, 3, 4, 5. It's a bit too big, a bit too short. I can extend it a bit until I get to the correct width. Okay, now I have 5 even divisions. Five even divisions. Let me just split it up into 5 equal spaces. And then I have to, okay, this is going to be a bit not such a good scale because my sine graph needs to go up, down, up, up, down, up, up, down, up, up, down, up, up, down, up. So can I just modify a bit more? Hold on a second. Let me just stretch it out. So I'll change my 360, sorry, my 180 to the 360's position so I can stretch out my graph a bit more. Middle line. Yeah, never mind, later. Let me stretch it all the way until it's something like this. Okay, close enough. Now draw a bunch of dotted lines, split up into 5 equal sections. Still not a very, still not a lot of space, but I think this will have to do. Okay, then let me erase these guys, and then I'll draw my middle line right here. Oh, wait, I could do this. And then I proceed to draw 5 copies of the same graph. Go up, go down, go down, go up. Go up, go down, go down, go up. Just make sure it's equally spaced. It won't be exactly perfect, but it's okay. All right, am I done? Oh no, one more. One more. Go up, go down, go down, go up. I think my horizontal line wasn't very horizontal. Yeah, but you get the idea, right? 5 copies. Okay, yeah, then we're done. Okay, oh, sorry. Let me just adjust like this. Y equals 10t degrees. Origin. Okay, make sure you got the Y, you got the T, you got the origin, you got the equation of the graph, you got the maximum, you got the minimum, and the middle line. Okay, middle line may be optional, but make sure you have maximum and minimum. And you label the 180 degrees. Should be a solid circle here as well. Okay. Can? Can okay, then that's all for the worksheet. Let's go on to the what's it called? Swiss cottage. Sorry, I haven't had enough time to mark all the papers, but I've marked a few of the questions already. Question 1, 2, and 3 is fine. Question 4, please remember to answer the question. They requested for coordinates of A and B, so you need to present your answer like this. Okay, yeah, just presentation only. You got the right answer. Then question 5, part 1 is fine. To find AX, you don't have to use sine rule because we have a 90-degree triangle. we can actually just use Pythagoras theorem. So, but your working is fine, huh? You'll get the same answer. Square root 48. Square root 48. And also over here, you could have used cosine 60 degrees equals AY over 8 for question 5. Right? Yes. So okay lah, huh? You can go and figure that out. But yeah, then the rest is fine. How about question 6? Here, actually nothing wrong. Your working is perfectly fine.
Wait,
Sorry, yes.
Oh yeah, no, go on.
You just need to make sure that you figure out which quadrant the angle A is in. Then you will have an easier time. Because what did they tell you? They told you that tangent A and sine A have different signs, right? So tangent A is positive 8 over 15, and then sine A is negative whatever. Doesn't matter what that value of sine A is, you just need to know it's negative and positive. Then from there, you can deduce A is in what quadrant, A is in what quadrant. Then from there, you find the overlapping. It must be in quadrant 3 only.
Oh,
A must be in quadrant 3. Okay? It's not both. It's only quadrant 3. It's only quadrant 3. So maybe I'll get rid of this circle. You should be just quadrant 3. Okay? Yeah, then the rest of your working is fine. Huh? Nothing wrong. Everything is correct. I got nothing to say. Yeah. So okay. Next one. Question 7. I haven't read yet. Let's see. Question 7 asks you to sketch the curve y equal e power 2x plus 1 minus 3. Right? So how we should do with it is maybe we do a bit of transformation. So we start off with the basic e power x. Right? Then we want to convert it eventually step by step into e power 2x plus 1, then later minus 3. So in general, there is this sequence of transformations. It's actually a H2 math topic called graphical transformation, but I'm just going to introduce it. Here, the f of x, you can treat it as the e power x. Okay? And then the transformations that you should follow should always follow in this sequence. Letter A, then letter B, then C, then D. Inside the what we call the argument of the function, f bracket something, right? You need to have a translation, plus or minus A. So in this case, how do you link x and 2x plus 1? What do you think is the A? The x is inside the bracket, must change to bx plus A. The x is currently just a single x, must transform into 2x plus 1. What do you think is A?
What is A?
Look at the arrow. Let me write it down like this. 2x plus. A is 1, right? So that's your first step. You should convert it from e power x to e power x plus 1. Now, I'm not sure if you know this. I never talked about it. But whenever you plus 1 to the x, your graph will move towards the left by 1 unit. Plus will make the graph move left. Minus will make the graph move right. Okay? Only if it's in the argument of the function inside the x. So yeah, so let's see how the graph will look now. At first it was e power x, so here's how it will look. It will pass through, okay, it shouldn't cut the x-axis. It's very, very close to x-axis, but then eventually it will cut through 0, 1, and then it will just shoot up very, very fast, exponentially. Then after that, when you move 1 unit to the left, what happens? Well, it's essentially like this. Here, is it still 0, 1? No, it becomes 0 to the power of. There is 0, e power 0 plus 1, which is e. Okay, 0, e. It's not 1, 1. Yes, actually that's also true. It will also pass through 1, 1. No, that's not true. That's not true. Hold on a second.
1,
Yes, correct. Minus 1, 1 is better. Yes. Because e is larger than 1. That guy is minus 1, 1. Okay, then after that, you transform it further. Now you have what? Y equals to e power 2x plus 1. What happens then? Whenever you times 2 to the x, what happens is that you squish the graph by half. The reciprocal of 2. So what happens to your graph? You get squished by half. So all the x values will have to divide by 2 while the y values stay the same. So we currently have what? Maybe I think it's nicer if I just draw this more nicely. what happens is that you are going to keep all of the y coordinates the same in your graph. So we currently have what 1 here and an e here, right? And then there's the corresponding x. We are now going to squish it by half, so divide by 2. 0 divided by 2 stays the same, so it's still 0, comma e. Negative 1 divided by 2 becomes negative half, comma 1. So negative half, comma 1. And then now you connect the dots. And hopefully you realize that the graph essentially got squished. It became tighter, like towards the width became like smaller. Previously it was this amount, now it's only this tiny amount. The width gets smaller. You get squished by half, or what we call formally scaling parallel to the x-axis by a scale factor of 1/2. Is that okay? Okay, yeah, it essentially becomes steeper. Then next, we finally have the last transformation, which is to convert from y equals e power 2x plus 1 to y equals e power 2x plus 1, but with an extra minus 3. Now this minus 3, previously I tell you plus and minus on the x, it will move it left and right. Now this minus 3, sorry, let me try again. When you plus and minus a number inside the f of x, you will move it left and right. Now when you minus 3 or plus 3, but it's outside of the f, instead of moving left and right, what do you think it will happen? What will it do to the graph? Instead of left and right, what other direction? Make a good guess.
Up and down. Down.
Up and down, exactly. Correct. Minus 3 will move it down. Because you can think of it like this. All of the original y values, you can think of this as y old, and this one is y new. This guy here is just the same as the previous one, which is y old. So y new is now equals to y old, but minus 3. What does that mean? It means that all of your previous y values must reduce by 3. The x stay the same. So if that happens, essentially the graph moves down by 3 units. The graph moves down by 3 units. So I'll just copy that same diagram above, but all the x stays the same. All the x stays the same. The y needs to minus 3. Okay, so E is around 2.7. So minus 3 will go below the x-axis already. So it'll look something like this. Also, there's the y equals to 0 horizontal asymptote. It will now move 3 units down as well. So it's y equals negative 3. Everything else, the x-axis, the x coordinate stays the same, but the y need to minus 3. So 1 minus 3 is negative 2. And what was that point just now? 0, comma e now becomes 0, comma, I'm running out of space. 0, comma e minus 3. Okay, then introduce, and just so happens that there's a new x-intercept introduced. So you can just label the coordinates. Something, comma 0. I don't know. Let me think. Substitute y equal to 0, you're left with 0 equals to e power 2x plus 1 minus 3. Then in that case, I'll just change it to red color. You have to solve for x. Let's see. E power 2x plus 1 equals to positive 3. 2x plus 1 equals to ln of 3 log base e. Then x equals to ln 3, subtract away 1, divide by 2. Let's just approximate it in decimals. ln 3 minus 1 divide by 2. 0.0493 approximately. Okay, is that what you draw? What you drew? Here, negative 3. Negative 3. Okay, Ken, your graph looks fine. Okay.
Okay.
It's just that, wait. This part should be negative. Maybe I cannot see your negative sign. Oh, negative 0.282. Yeah. All right, good. Okay, that's transformations. Next. How about part 2? In order to solve the equation ln x plus 6 minus 1 equal to 2x, a graph of a circular line is drawn on the same set of axes as the original graph. Find the equation of this straight line. So yeah, how you need to do it is you must begin with what you want. Okay, this is what you want, the original graph. Then what you currently have is ln x plus 6 bracket minus 1 equals 2x. Your goal is to rewrite this guy, work with what you have towards what you want. So you need to force out e power 2x plus 1 minus 3. Okay? Right? So now how do you get an e power from a ln? You need to bring the base e over, right? Remember the log base e idea? But here,
plus 1 first.
you need to plus 1 first. Correct. Your ln must be on its own. The log must be on its own. So in this case, log being base e, so it's ln. Ln x plus 6 equals to 2x plus 1 after you brought the minus 1 over. Then x plus 6 must be equals to e to the power of 2x plus 1. Are we there yet? Not really. We still need what's missing?
Minus 3.
Minus 3. So I want to write it all on the same page so it looks nicer. Okay, something like this. Then you can minus 3 now if you want to have the minus 3. But must make sure to do it on both sides of the equation to be balanced. Minus 3 on the right side, you minus 3 on the left as well. Do you understand why I minus 3 here? Yes, right? Because we want the y equals e power 2x plus 1 minus 3. So now we can just substitute the right hand side with our y. Of course, it could also appear on the left hand side. Depends on how you worked it out. X plus 6 minus 3. 6 minus 3 is just 3, so x plus 3. So what's the equation you have to draw now? Draw. Find the equation of the straight line. Y equal x plus 3. Okay, so let's just copy the diagram we drew previously. I'll just use your diagram. Where is x plus 3? 3 is probably somewhere here. Maybe here. Then I have to draw x plus 3, so somewhere like this. Positive gradient. Okay, then your curve, I'll just continue extending it. You'll see that there's an intersection here and here, right? So just draw a point of intersection, go towards x-axis. Point of intersection, go towards the x-axis. Yeah, so part B says, by sketching this line on the same axis as part 1, determine the number of solutions. So what do you think is the number of solutions?
Is 2.
2, exactly. Okay, so this is the same idea as the trigo graph, right? You just need to start with a y1, start with a y2, equate them simultaneously, and then manipulate it so that you can draw the correct line. Okay, so yeah, start with what you want, then write down what you want first, then you write down what you currently have, what was the given equation, then you slowly work your way towards what you want. Eventually you get to this guy here, then you can replace with a y. Okay. So the answer is 2. 2 POI, point of intersections. Point of intersections. Maybe this one E can bring over. Okay, moving on. So question 8. Oh, you can do already. Prove the identity. This one is supposed to be the new topic I want to start today, but not sure if I have time, if I need to go through everything. Okay, since you already did it, let's just mark it. Okay, secant x minus tangent x times cosecant x plus 1, you need to show that it's equal to cotangent x. So you replace it with 1 over cosine, sine over cosine, 1 over sine plus 1. Okay, then you combine the fractions. Denominator, both cosine just add together. 1 minus sine x over cosine x. That's good. 1 plus sine x over sine x. Yes, because 1 is the same as sine x over sine x. This is good. 1 minus sine times 1 plus sine is a minus b times a plus b. So a square minus b square, 1 square minus sine square on the numerator. Then bottom is cosine x times sine x. Very good. What was our objective again? Cotangent x, which is cosine over sine. Then how do you bridge the gap? oh, you realize that there's the magic identity. This is called the Pythagorean identity. Okay, because it's based on Pythagoras theorem. Oh, sine square plus cosine square equal to 1, but you rewrite the 1 minus sine square as cosine square. And then, what a coincidence. Cosine 2 copies, cosine 1 copy. Cancel away 1 copy of cosine. You're left with cosine over sine, which is cotangent. Okay, good. Well, maybe I don't need to go through the topic early. Trigo identities. Okay, I can go faster. Okay, later. Yeah, then you have proven part 1. Very good. Hence, for part 2, find all the angles between 0 and 360 which satisfy the following equation. So what you need to do is to, yes, use the identity from part 1 after you multiply over. Yeah, you get 5 over 6. Then this is just cotangent. 1 over tangent. Flip it around, you get tangent. Then you can find alpha tangent inverse. Let me see if it's correct. Here they are requesting for angles between 0 degrees and 360 degrees. So you just use degree mode. Don't need to change to radian mode. But be careful, sometimes they may ask between 0 and 2 pi. If they say 2 pi, then you must make sure you are in radian mode when you find your alpha. But your answer here is fine. So x is 50.2 in 1 dp, and tangent here in this case is positive, so it's quadrant 1, 2, that's 3. So it's just the alpha itself, or 180 plus alpha. Yes, good. Round off to 1 dp. Very good. Okay, question 9a. Let's see the answer. Is it right? Hmm. 102 divided by 10 is 10 and 1/5. Okay, can correct. Good. B A equals 7, B equals -2. Yes. Question 10a part 1. Something wrong. Let's see. Okay. So this one, I did not go through with you because it has been removed from the syllabus already. Do you want to go?
What is it?
This guy. So you realize it looks a lot like a graph you have seen before, right? Like let's say you have y equals to 5x squared. You see a square here? Then what kind of curve do you call this? Quadratic curve. How does it look? Happy face, right? Because positive coefficient here. Right? But that is when the square is power 2 is on the x. Now the power 2, what happens if it's on the y? Yeah, it will have to curve sideways. But then you must now determine, should it be towards the left or towards the right? This way, that way. Which one?
I guess this way.
How I will do it is, what we are doing here is essentially finding a square root function. You see, y squared equal -2x, -2x is asking you, hey, hold on a second, there's a negative sign. Okay, wait, no. Here's how I'll do it. I'll treat it as an inverse function. So you can think of this as x squared equals -2y. Okay, you swap the x and the y first. Then you solve for y. So y equals to -12 x squared, right? Then from there, you know how to draw the graph, right? Let's draw the graph. So -12 x squared. So set face. And the y-intercept is 0. So it must look something like this. Agree so far? Now, when you want to find the original graph, which is before swapping around the x with the y, you're essentially gonna swap this x and y around. So I can do this. Just change this to x, change this to y, and we are done. But typically, when the question asks you for sketch the graph of this guy, they want the vertical to be y and the horizontal to be x. Your graph is already correct, but how do we make transform it so that x become y, y become x? Here's how you do it. Think of this as like a mirror reflection about this y equal to x. Okay, can you imagine how it will look like after you reflect about this y equal to x? Imagine a satay stick, and then you rotate the satay stick 180 degrees. What will happen to your set face curve? Where does it go? No.
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 Wait, how?
Think about it. We reflect across this line. If it was like this, it will curve like this. E
Yeah.
power x becomes ln x. If it was a set phasor, what happens?
Wait, no. Like,
Reflect about y equal to x. Where is y equal to x? It's over here. It will intersect here at -1, 1. Can see or not? Or should I review the answer?
how?
No. Should I review the answer?
Okay.
Yeah, it looks like this. Can you see? Mirror image.
Okay.
Right? Then that's the answer. Okay, that's how I do it. I replace my y and x first with the opposite. Then I solve for y as a normal quadratic equation. Then I draw that black color curve. But my vertical is, but yeah, it's with y and x. But then now I remember, oh, the original question actually swapped the x and y around. So I replace my y with x, replace the x with y. Then if I reflect it around, sorry, maybe I shouldn't have drawn it on the same curve. This reflected version, right, is actually along a different set of x's. Now this is y and that is x. Does it make sense?
Mm.
Hopefully, I don't know. It's already been removed from the syllabus for quite a few years because it requires the topic of inverse function, but it wasn't formal. It is not formally in the AMAX syllabus. It's only in H2 Max. You need to know. You definitely need to know this for H2, like A level. Yeah.
Mm.
So yeah, I'll just briefly talk about it only. Okay, Ken. Then how about the part? What was the other part of the question? Oh, sketch on the same axis the graphs of y squared equal minus 2x. Okay, done. We still need a -5 over x squared. So you already know how our 1 over x squared graph looks like, right? If you times 5, you're just making the volcano steeper, the volcano, right? But now there's a negative. Negative means you reflect it about the x-axis, so it goes downwards instead. So your curve must look something like, I'll just use red color, here and here. Okay? Maybe I'll label it. This guy is y equals -5 over x squared. I need more space. Give me a second. I need to start a new page. This is question 10 now. Question 10a, part 1. Yeah. So this guy here is y squared equals minus 2x. Intersection at origin. This is y equals -5 over x squared. Okay, and they have a point of intersection here, so you probably need to find the coordinates. But I think that's what part 2 is asking you to do. State the value of k for which the x coordinate of the points of intersection satisfies the equation x power 5 equals to k. So this one, so strange. How come got x power 5? But don't worry about it. Just look at x coordinate of the what? You have got the question paper on?
Yeah.
Yeah, x coordinate of the points of intersection. Whenever you hear this phrase point of intersection, you know simultaneous equation is what they're asking you to do. Okay, they're asking you to find the point of intersection between these two graphs. And that's just I will just substitute -5 over x squared into the equation 1. 2 into 1, sub 2 into 1. Which means I'll end up with a square here equals -2x. Is that okay? Then I'll end up with -5 square, x squared square equals -2x. Positive 25 over x power 4 equals -2x. Right, so when you do it simultaneously, you're essentially just finding the point of intersection over here, the coordinates. But that x value, we don't really care what that value is, because that's not what the question is asking, and also it's quite difficult to find. You just need to solve them simultaneously and then manipulate it so that it forms the equation that it gave you, x power 5 equals k. Can you see how this is slowly becoming x power 5? Just times over, right?
Okay.
Can you see? Oh, sorry, power 4. Yeah, just cross multiply. And then eventually, finally, okay, this is negative 2x power 5 equals 25. And then finally, x power 5 equals to 25 divided by negative 2. So what is k? Negative 25. Yeah, exactly. This is k. Okay. Yeah.
Okay.
Part B. Now, how to what was your answer for part B? Let me see. Is it the same as the given answer, half x minus 2y minus 1? Yes. Okay, then I don't go through. 11, God. So many small angles, 0.7, 129.3, 180.7, 309.3. Yeah, it's a standard question, nothing much. Part B, Part B is given that x is in between 0 to 6. Here, you know, actually radians is unitless. So when they say 0 less than equal x less than equal 6, they are referring to 0 radians and 6 radians. Because if you recall, what is radians? Radians is theta equal s over r, right? Where you have a sector like this with radius r and the angle theta radians. And the arc length, the curvy part, is s. If this is in cm, r must also be in cm. What happens when you take cm divided by cm?
No
They'll
unit.
cancel away. That's why there's no more units. Okay. Yeah, that's why there's no more units. It's by definition. Okay, but yeah, so how to solve this question? The trick here is to use some special identities. Do you notice that there's sine square and there's cosine square?
Uh-huh.
Yeah, new page. Is there an identity involving sine square and cosine square you recall?
Sine square plus cosine square equal 1.
Correct, exactly. So let me just copy down the equation first. So question 11b. Yeah, so the hint is quadratic. The hint is quadratic equation. So which version would you like to use? Sine square x, sorry, I forgot to put an x. Sine square x plus cosine square x equals to 1. Sine squared equals 1 minus cosine square x. Cosine square x equals 1 minus sine square x. Sometimes I will be lazy and I don't pronounce the x, but it's supposed to be there. Can you tell me which one would you want to use this? Use sine square. Can I just advise you first? This guy is usually useless. The first one is useless. The other two are more useful. Right? You can directly substitute it. So you decided to go for 1 minus cos squared. Very good. I'm just copying what you're writing. Continue. Okay, 3 minus 3 cos squared plus cos x equals cos squared. Very good. So what kind of equation is this?
You sub like, I don't know, equal this thing.
Is it
Yeah.
cosine square or just cosine?
I mean cosine.
Just cosine.
Then it's quadratic.
And you get a quadratic, yes. And then you know how to solve already. Should I just show you the working?
I mean, you can show me.
Okay, I'll just show. Yeah, I think you already know how to solve this. So basically, yes, you're correct. Just replace the cosine with alpha or y. Maybe I will clean up a bit more. Here got minus 3 copies. Here got plus 1 copy. I'll bring this over, so I get minus 4 copies of cosine square x. Don't forget the 3. Don't forget the cosine. And then 0 on the right hand side because I bring over already. Then you can just let capital Y equals to cosine x. You're left with 3 minus 4y squared plus y equals 0. What kind of equation is this? Quadratic equation. A hidden quadratic equation after you do the substitution. Then just use a calculator, solve. -4, 1, 3. And you end up with y capital Y, not cosine x yet, equals to 1, or y equals -3/4. Are we done? Not done. Why? Because we don't want y. Why? Because we don't want y. We want cosine. We want x. So we have to sub that y back with cosine x. And then proceed to solve. Can I leave this to you? This one, you draw graph. You don't go and cosine inverse. For whenever the right hand side, recall, when it is 1, -1, or 0, these three special values, please don't use cosine inverse. Just draw a graph. What else? That only applies to cosine or sine. Maybe I'll write it at the side. Cosine x or sine x. If it's tangent x, just every time it's a tangent x equals to blah, anything. Or maybe I don't say blah, I say anything. Any. Tangent x, this one just tangent inverse. Find the alpha. The positive value of any to get the acute angle. Don't need to draw a graph. The graph is not so useful. Yeah, okay, Ken, moving on. The next question, question 12. Radioactive follows the equation n equals 180 e power -kt, where n is the substance left and t is the number of days that passed. You half after 3.5 days, so 3.5 is also known as the half-life. Sounds like a game. I'm not sure, I don't play. Half-life. The part 1 is find the initial amount, so substitute t with 0, you get 180, yep. Value of k, so t, it's halved, right? So that means you'll just drop from 180 times half to 90, but that's after 3.5 days, so sub t with 3.5. Solve for k, you get 0.198. Let's see, is it right? Yeah, correct. Good. Then for part 3 is asking the number of days it will take before the amount of substance is reduced to 6 grams. So n you substitute with 6, k you substitute with what you just found. Yep, and then you solve for t. Okay. So the t is 18. Yeah, you have to round up. Did they mention? Yeah, you have to round up. If not, you will not be able to have the substance to be reduced to 6. It will still be slightly above 6. Okay, then part 4, the amount of substance remaining after 1 week. 1 week is 7 days, so you just substitute t with 7. Yep. And you get 44.9. Their answer, they gave 45.0. You use the more accurate answer, right? So I think your answer is more accurate. I will accept. Yes? Ken? Moving on. Okay, question 13, partial fractions. This form is fine. Correct, 1 degree less bx plus c. Very good. Just the tricky thing you must remember is when there's like repeated roots, then you need to put like a few copies. You remember repeated roots? Like x minus 1 squared and x plus 1. There's distinct roots. Minus 1 and plus 1 is different, but this minus 1 got repetition, power 2. So you can rewrite it as a over x minus 1, then x minus 1 bracket square. This one must be still a constant b, not bx plus c, okay? And then plus a c over x plus 1. Or if you change this to, I don't know, instead of x plus 1, you change to x square plus 1, then in that case, it will be not c over x plus 1, it's cx plus d over x squared plus 1. Now, you don't really need to deal with this kind of equations because there's 4 unknowns, a bit too difficult to solve. This is the general version already. Okay? This is just for example. Okay, let's see your answer. Is it right or wrong? -6 and 6x plus 3 over 5. Yes, good. And part B, you want to, straight away you see degree 2 is the same. So it's an improper fraction you have to do, long division. Did you get that? Let me see. Yep. Okay, good. Then after that, you do long division. I'm sorry, partial fractions on this fraction here. Leave the 1 alone. Eventually, you get to 1 plus 31 over 7x minus 6 and minus 3 over 7x plus 1. Oh yeah, by the way, please make sure you remember how to do partial fractions because we will use that later on in integration calculus. Differentiation, integration. You must know how to do partial fractions. Okay? Okay, can. Or basically everything. Differentiation, integration, you need to know everything that comes before that I've been teaching you so far. Okay, now for this absolute value. Then go recap. We will start that, I think, next lesson. Differentiation. Actually, no. Next lesson. This lesson, after I go through this list, I will finish up with the trigo identities. Is that a bit too much? Okay, I'll start talking about trigo identities a bit more in details, and then later on I will talk about R formula if I have enough time today. If not, then I will go next week. I'll talk about R formula. We'll do practice questions. Then after that, next week it will be on differentiation already. Okay. Can yeah. So next, go question 14. The diagram below, it shows part of the graph y equal modulus 3x plus y minus 2. So I didn't teach you modulus yet because it has already been removed from the syllabus, but this is an older paper, that's why they still include this. Here is how the function looks. What is modulus? I should write down modulus. Or you can also call it absolute value. They mean the same thing. Or you can even call this the distance function. It basically says, takes the x and it makes it into positive. If it is negative, it turns it into positive. If it is 0, it remains as 0. If it is positive, it remains as positive. So how does it look? When the x here is positive, it will just be the normal y equal to x. When it's 0, it stays at 0. But what happens when x here is negative? You have to times negative 1. So instead of going downwards, it actually goes upwards. So you get a V shape, a very, very sharp point here. Okay. In general, here's how you write it. Y equals to modulus x is equals to, this is what we call a piecewise function. Piece by piece, we define it piece by piece. Can you see clearly that there are two pieces here? Left piece and right piece, like a peace sign. How to draw? I can't draw hands. Okay, peace sign. So now you have x or negative x. Two cases. If it will remain as x, the green color part, if your x is more than 0, and it will become the blue part negative x. Right, this is just y equal negative x. Okay, y equals negative x. That one is just y equal x combined together. When x is less than 0. Do you notice something missing here? This is like the condition and the corresponding output. The input and the output. What's a missing input?
Missing x equals 0.
X equals 0. But which one should it belong? Either one, because once you sub in 0 here, it's still 0. Negative 0, also 0. So we can just put the equal sign either here or there. But you do not put on both places. If I do that, it means I made a mistake. Okay? If I put equal sign on both places, it means I made a mistake. But usually it's a forgivable mistake because the value will still be the same, regardless of which what we call the rule. This part here is called the rule. Regardless of the rule that you use. This part here is called the domain. The inputs. Okay. Okay, can Then there's still one more phrase that's already going into H2 math already. It's called the range. It's the allowed y values. Can you tell what's the range of this function? What are the allowed y values? Can it be negative?
No.
No. Can it be 0?
Yeah.
Yes, when x is 0, it can be 0. How about, can it be positive?
Yeah.
Yes, so the range, okay, this is extra knowledge already, not part of Amax anymore. Range is actually, in this case, y more than equals 0. Okay, it's the possible y values. Range is called the possible y values. Okay, wait, I think pink can look, pink can have contrast with black. Okay, possible y values. All right. Yeah, this is extra, don't need to know. But that is basically modulus x. So in general, actually your x doesn't have to be an x. You can imagine if now we change it into what happens if we change it to cosine x. Original cosine goes down, down, up, up. But if we now take the modulus, what happens to the graph? The one that's at the bottom, this part I'll change it to maybe pink color. Then the original, the modulus will actually bring it on top, reflected about the x-axis. It goes up. Can you see? So this entire modulus cosine x is how this function will look. Then you can imagine now if I start telling you, hey, what if I have y equals modulus cosine x and y equals to 1 over pi x plus 1, or maybe plus 0.5. Can you find the number of point of intersections? You can imagine how difficult this question will be. Not really, just plot a few points, but you have to be accurate with your drawing. But the prerequisite is you need to really, really, really be familiar with your trigo graphs already before you deal with the absolute value function. Absolute value function, very simple. You just need to bring the bottom to the top. That's all. You don't even need the bottom anymore. I'll just make it dotted line. Okay. So yeah, this one is a bonus question. Okay, find the number of point of intersection. Find, this is y1, this is y2. Find the number, hashtag means number, of POI between y1 and y2. Okay, but anyway, back to the original question 14. So you want to draw the graph of, wait, huh? What are you drawing now? Oh, sorry, I'm not sure. Yeah, let's read the question first. So you got y equals modulus 3x plus 5 minus 2. So yeah, so y equals modulus 3x plus 5 and minus 2. Sorry, I didn't read what you are writing. You're plotting a few points. Okay, can also, but I think it's easier if we just draw the graph of y equals 3x plus 5 first. So here's what I'll do. Step 1, draw y equals 3x plus 5 first as a sketch. That's not the final answer, yeah. 3x plus 5, y-intercept is 5, positive gradient, so something like this. Okay. Then y-intercept here, sorry, x-intercept here, you just sub in y with 0, so 0 equals 3x plus 5. Solving for x, you get negative 5 over 3. Clear so far? Okay, then after that, you draw y equals modulus 3x plus 5. Also, you see I'm doing it step by step. I start with the innermost function, then I work my way outwards, modulus it. Later, then I put a minus 2. So how does the modulus graph look? You simply reflect. If this is 5 and negative 5/3, when it goes below negative 5/3, what happens? It is now negative y values, right? So you just have to take that modulus, sorry, take that bottom part and go up. So your graph will now go upwards like this. Make sure it's symmetrical. Is that okay?
Mm-hmm.
So what do you think is the equation of this guy here?
Equation.
If like, let's say you want this guy here, this green color line here, what's the equation of this line? Y equals what? Mx plus c.
Or minus m.
Yes.
Negative 3x plus 5.
Is it still plus 5?
I don't know.
No. Plus 5 is what? The y-intercept is, where is the y-intercept of the green graph? Is it still positive 5?
No, negative.
Negative 5. So actually, let me think a bit. Is it negative 5? Let's just keep it as a plus c. Since we know it passes through -5/3, 0, let's just substitute in. Sub in x equals -5/3, y equals 0. Oh, so in that case, we get 0 equals -3 times -5/3 plus c. Minus 3 cancel away. You're left with just a 5 plus c. So c equals -5. Yes, correct. Okay. Yeah, it's just a reflection. Oh, 5 becomes -5. Then the x becomes -3x, I believe. So yeah, okay, good. So it's just -5. Let me get rid of that. So the graph equation is y equals -3x minus 5. But that's just extra knowledge, not relevant to the question. This is the original modulus 3x plus 5. Step 3 now is for us to draw the final sketch. You just need to do what when you have a -2 here? Is it part of the inside of the x or is it outside of the x?
Outside.
If it is outside, does it move left, right, or up, down?
Down 2.
Up, down. In this case, -2, so down. Okay, so you go down by 2 units and then you're done. So 5 will drop to 3 and -5 third, 0 will drop to -5 third, -2. Okay, so this point here is -5 third, -2. That point there is instead of 0,5, it's 0,5 minus 2, which is 3. Okay, or just 3 just label a 3 can already. Let me erase and write down 3. Is that okay? Then that's the sketch. So that's what they gave you. Then from there you need to figure out what's ABC. So A, I think is quite clear. A is just 0,3. B and C, this one have to think a little bit. Oops. Have to think a little bit. So we need to figure out the equation of the graph. Previously, okay, maybe I'll label blue color here as the original graph 3x plus 5. I'll highlight it in blue as well. And then we got the green one, y equals -3x minus 5. Now we have these two functions, okay? The 3x plus 5 minus 3x minus 5. We shifted it down by 2. What do you think is the updated function now? Can it still be the same? No, right? It has to shift down by 2. So we need to minus 2. In other words, this is just 3x plus 3. Is that clear?
Okay.
The equation on the right side, maybe I'll highlight it purple to be this guy. I'll just highlight 3x plus 3. What else? We also got the light blue part. What do you think is the equation of the light blue part? Y equals? Previously it was green, now it becomes light blue. Shift down by 2.
Minus 3x minus 7.
Very good, exactly. Just -5 minus 2 and you get -7. That's it. Easy, right? Absolute value function. Quite an easy topic. I'm not sure why it was removed from the syllabus, but yeah. Now you know these two equations. Can you find the x-intercepts of B and C?
Okay.
Yes, right? You just need to sub for B, for B. I'll call this equation 1 and equation 2. Very messy. Sorry, let me try again. I'll move my words away. This is equation 2. Then I'll say for point B, sub y equals 0 into 1. Okay, so we get 0 equals 3x plus 3. Solving, you end up with x equals to -1. So therefore, coordinates of B is -1, 0. And for point C, what do you think? Sub what? Wow, no space, very messy. Can I just move my working downwards a bit? Yeah, sorry, sub what?
Y equals 0
Into point C.
into y equals to -3x minus 7.
Equation 2. Right, I labeled 2 here. So don't need to write so much. And then you just substitute there already. Y equals -3x minus 7. Solving, you get 3x equal -7. So x equals to -7 divided by 3. And sorry, that's not the answer we want. We want to give coordinates. So -7/3, 0. Okay, they ask for a point. That means you give coordinates. Actually, they said coordinates of the points. They were very clear about what they are requesting for. They are not asking for the -1. They are not asking for -7/3. They're asking for coordinates. So you must put the 0, 0. If not, you won't get the answer mark. Okay, can. Very good. Now, part 1 is done. Let's move on to part 2. So how to solve modulus equations? Wow, this one is a crash course on modulus already. I think this will be all I need to go through on modulus once you're able to understand this question. So for modulus functions, what you need to understand is that it is a bit like square root where you have to consider plus and minus. Right? When you take square root, remember you need to take plus minus.
Okay.
Same thing over here. When you open up the modulus, you also need to consider two cases, plus or minus. So what I like to do is to isolate the modulus. So this becomes +6. Then I split it up as 3x plus 5 equals to positive x plus 6. Or I don't need to put a plus sign. 3x plus 5 equals to negative bracket x plus 6. Okay. Yeah, then you continue to proceed to solve it. Why do we need plus and minus? It's because there are essentially two lines here. 3x plus 5, there's the positive 3x plus 5 and the negative, the green one, minus 3x minus 5. Okay, so we are sort of solving two simultaneous equations at the same time. This translates into drawing the 3x plus 5 curve, and then you draw the x plus 6 curve. Do you understand?
Okay.
3x plus 5 is over here, x plus 6 is over there. And then you want to find the coordinates of these 2 points. So you're essentially solving, what was the color code I used? Blue for this one, green for that one. And then this guy, maybe I'll use gray color. You're solving two simultaneous equations, green with gray and blue with gray, which is this guy and that guy. Okay, but I just decide to put the minus on the right side. I could always bring it to the left. Okay, maybe just to follow my picture, it's essentially what we are doing is these two sets of equations, which is equivalent to gray with blue and gray with green. Yeah, correct. Can? Then you just solve for x. Okay, let's just jump straight to the answer. So solving, I'm sure you know how to do that. So 2x equals to 1, x equal to half. And then this one, I don't know. I like to bring my minus to the other side. So minus x minus 6, bring over the x, 4x, bring over the 5, I get minus 11. Then I get x equals minus 11 over 4. Don't forget to find the y coordinate. So y equals to, in this case, it lies along x plus 6. So I can sub in into x plus 6. So half plus 6, 6 half. This one plus 6, I need a calculator for this. (13 over 4). Okay, and those are your two solutions, half, 6 half. Or, sorry, not or, this is solution, sorry. And minus 11 over 4, 13 over 4. Okay. Alternatively, you could use graphing software to help you to solve this. Just draw the graph of the left-hand side, draw the graph of the right-hand side, and then you will be able to find the point of intersection. Do you want me to show you on Desmos how to draw the graph?
Okay.
And get these answers straight away. Okay, give me a second. Oh no, not enough time. I need to go through identities. Wrong. I need to share this one. That was Pokemon. Let me share the correct screen. This guy. Okay, let's go to this guy. That's more. So we're gonna draw the graph of the y equals to. From the beginning, we have the modulus 3x plus 5, right? So we can draw a vertical line, then 3x plus 5. The vertical line is above your enter sign on your keyboard if you want to try on your own. This is 3x plus 5 minus 2. Then you have a x plus 4, y equals. Then what you realize, they intersect over here and there, and the graphing calculator will immediately give you the answer. Instead of, but what I just showed you was the manual way to do it. Okay?
Okay.
Yeah. Okay, that's the demonstration. Done. I mean, I'm not sure. Maybe in the future, if you can go to university, it's quite likely that you'll be able to have access to computers, so you won't need to solve this manually. So yeah, it's just good to know only manually. But that's the basis for the math. You can always use software to help you to solve. Okay, for now for part 3, this one maybe not so easy to use software because there's a unknown m. Find the number of solutions of the equation blah 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 equals to mx plus 4 when m equals -1, m equals to 3. So here is when you have to be creative already. You must remember that the previous part 2 we had this guy, x plus 4, 1 x plus 4. Now they are just changing the gradient here to m. Okay, previously it was m equal to 1 in part 2. Now we are changing the m to -1 or +3. So how does the curve look again? This guy, maybe I should make it a bit steeper. Sorry, this because it's gradient +3, and it intersects at 5. Then there was a mx plus 4, so it's +4, which means that it is slightly below here at 4, and the gradient is less steep than 3. This one m equal to 3, this one m equals to 1. Right? That was from part 2. Did I draw wrongly? I think. Yeah, I think my graph draw wrongly. I should have made it a bit steeper. Sorry. I mean my gray graph should be below. Let me try and adjust this. Yeah, that's a bit more accurate. Yeah, because the 4 is below 5. Here the y-intercept 5, y-intercept 4. What's the color? Green color. Okay. Yeah, so anyways, this is how the part 2 graph looks. But now we are trying to change this fella here. The y-intercept, y equal mx plus 4, where m equal to 1 looks like this. But if we change the m and we keep the 4, what happens to this black color graph? Can you imagine? Now I want to draw y equals to, instead of 1x, I want -1x plus 4.
Goes downward or
right. But what stays the same? Which intercept stays the same?
x intercept. I mean
this guy
y
stays
intercept.
Y intercept. The 4 stays the same. So that means that we'll end up with, okay, this guy, I'll draw it in pink color. You'll go maybe something like this instead. Okay. Then what's the number of solutions? What's the number of solutions?
2.
2. Exactly. Now if you change it to 3, this is m equals to 3. What happened? Sorry, this is m equals to 1. Sorry. If we change it to m equal to 3, let me use a different color. Maybe I'll draw y equals to 3x plus 4 and I box it up in blue. How do I draw my graph? What stays the same?
Y-intercept.
Y-intercept still the same, so still pass through here. But what's the gradient now?
3.
What was the gradient of this guy? Also what gradient?
3.
This is 3x plus 5. That one was y equals to -3x minus 5. So what does it mean when you have equal gradient? This graph and this graph. Parallel. So that means that your blue graph actually looks like this. Sorry, let me try again. Parallel like this. So what's the number of solutions?
1.
Wrong. Must read carefully the question. They're asking for this versus that. You can think of this as y1 and y2, where y2 is currently 3x plus 4. What's your y1? Maybe I'll highlight it in
Wow.
orange. It's just the V shape, okay? Then the question is actually asking you currently, what is the number of point of intersection between the orange color V shape and the blue color?
0.
0, exactly. Let me show you how to do this with software. Is that okay?
Okay.
Maybe my drawing not so nice. I use software. You got the question paper with you?
Yep.
Okay, changing to decimal screen. Okay, so that 3x plus 5 is the red color curve on the V shape. Maybe I zoom out a bit. Like this, the V shape. Okay, then we want to draw the different values of mx plus 4. Mx plus 4, I can actually change the value of m as and when I like it like this. So if we have m equal to 1, this is the original function, but now part B, part part 3a and part 3b is asking for m equals -1 and -3. So if I change this to -1, take a look. Straight away, instantaneously, they will draw for me the graph. Can you instantly see that there are 2 point of intersections?
Yeah.
So number of point of intersection is 2. But if you change it to 3, oh, wait a minute. Oh, hold on a second. Did I mix things up? Oh, right, -2. I forgot about the -2. I drew my graph wrongly. Right, it's supposed to pass through 0, 3. So sorry about that. It's not a V shape. I forgot to -2 down. Was that why you were confused?
No.
No? Okay, but anyways, yeah, so I think from the graph you can see that they are parallel, so there's actually one solution here. So I made a mistake with my graph sketching. The correct answer should be 2 solutions and 1 solution. Can I just try again on the manual way?
Okay.
We draw the modulus 3x plus 5 minus 2. I forgot to shift the graph down by -2 units. By 2 units. Minus means you shift down. Okay, hold on a second. Let me erase all the previous graphs. This guy should be a 3. I move my graph up by 2 units. Okay, done. This is 3x plus 5 minus 2. This is 3x minus 3x minus 5 minus 2, which is minus 3x minus 7. Write it neatly. Y equals to minus 3x minus 5 minus 2, simplifying to minus 3x minus 7. Yeah, so this guy is 3x plus 3. That's why the y-intercept here is 3. The original first one, minus x plus 4, means you want it to pass through the y-intercept at 4, which is above. Here is 4. And then it has a -1 gradient, so it's less steep than the 3. So less steep, something like this. I'll draw it in pink again, like this. Okay, this guy is y equals minus x plus 4. Number of point of intersection is still 2. So maybe I'll move it here and here instead. Okay, right, still 2. Then the 3x plus 4, 3x plus 4 means y-intercept stays the same, but it has a gradient of 3, which is parallel to the right half of the V shape. The right half of the V shape. This guy and this guy are parallel, which means the number of point of intersection is just 1. But my graph is inaccurate. I should probably make it a little bit more downwards. Okay, but you get the idea, right? There will be 1 point of intersection.
Yep.
Okay, good. Okay, then that is all to this modulus. For paper 2, no time to go through. Can I not go through the part 2? I'm gonna start on Pythagorean identities already. Can?
Okay.
Okay, hold on. Let me go to the correct worksheet first. Okay, can we break for 2 minutes? I'll come back in 2. Can Hello, hello.
Hello.
Yes, okay, back. Now, I sent you a few files. Those will be your homework. I'll assign it later. I'll talk more about those later. But let's just begin with a few examples on trigger identities. So this is one of the files that you have seen before. We already used it many times. I'm just adding on to it, Trigger notes, so you can have a summarized notes. We already learned some identities previously, right? Like Torhaso, tangent is sine over cosine, and some of the negative angle identities, like here, negative angle identities, right? For sine and tangent, you must factor out. For cosine, you must drop it. Right? And then the special angle identities. Okay, is it my screen sharing? Can see, right?
Yeah.
Yes, huh? What else? We also have these guys, the complementary angle identities, complementary angles. And then what else we have? We have the cosecant, cotangent, and secant angle identities. Right? It's just a reciprocal. Co, no co idea. Co and no co. Maybe I should write this down. Co versus no co. And also Pythagorean identities, right? The three special identities. Sine square plus cosine square equal to 1, tangent square plus 1 equals secant square, and 1 plus cotangent square equals cosecant square. Yes?
Okay.
Yes, right? These three. And then I gave you the full formula list of all the formulas you need to know. But I have yet to go through these fella here. Okay, that's what I'm going to go through today. Can?
Okay.
Can? So let's go through the compound angle identities. Let me see. Should I start with that, or should I start with the trigo first? Okay. Okay. Maybe I'll start with just a recap on the first three identities. One example. Okay. So example. Dealing with the we're dealing with the Pythagorean identities. I'll just call this the P identity. PID. Example would be you want to prove the following: 1 plus sine x. Oh, sorry. Wait, hold on. 1 plus sine x all divided by sine x times cosine of x. You want to show that it is identical to tangent x plus cotangent x plus secant x. How would you approach this? Here's one strategy. You you start with the more complicated side. Okay, start with the more complicated side. Here, when you have a fraction, right, you can't really do anything. Maybe you could split up into two fractions, or like 1 over this one and sine over that one and add them together. But I think the right-hand side looks more complicated. Do you agree?
Okay.
Hopefully, yes. Then we start with the right-hand side. So I'll just copy and paste the right-hand side. Then when you're lost and confused, you see sines and cosines, you see non-sines and non-cosines, just convert everything into sine and cosine. So straight away, tangent is sine x over cosine x. Cotangent is cos x over sine x, right? The reciprocal of tangent. Right, co no co idea. Then secant is 1 over cosine. Is this clear so far?
Mm-hmm.
Very good. Then now you want to add fractions together. Now you have something to do. When you have fractions, you want to make one the same, denominator the same. So here you got cos, sine, and cos. LCM, sort of similar to the idea of lowest common multiple. It will be sine x times cosine x, right? How do you get cosine to sine cos? You have to multiply top and bottom by
Sine
so you get sine square x at
sine
the end.
square x plus cosine square x plus sine x.
Very good, exactly. Then what's so special about these two?
1.
It's just a 1. Okay, so sometimes it is useful. Remember I told you the 3 formats, right? Like for sine square plus cos square, I'll write this. This is the corrupted version. Corrupted version. S square plus C square. Do you know what it stands for?
Oh.
Yes, sine square plus cos square. Okay. So I told you that this one not so useful. These two are more useful, right? But sometimes, occasionally, it is useful. So this is the one rare case where it is. How do you spell occasionally? Occasionally useful, So in this case, you can replace it with 1 and then you are done. 1 plus sine x or over sine x cos x. Okay, very good. So you already know this. I will move on to introduce the new topic, new identity. Now we want to focus on the compound angle identities. Okay, this is graph sketching. I'm adding onto this page. Maybe I should have started a new page. Hold on a second. Let me think. How should I? Okay, I'll just continue. I'll rearrange the notes later and send it to you with a nicer format. Yeah, so now we're going to introduce new identities known as the compound angle formula. What's that? So you have seen before, example, sine of 40 degrees. You can always break it down into 30 plus 10, right? But the question is it the same as sine 30 degrees plus sine 10 degrees? Check with a calculator and you realize quickly that it is a no. It's not true. I mean, if you just look at the sine curve, like this, then here is 10 degrees, here is 30 degrees, here is 40 degrees, right? When we say sine 30 plus sine 10 over here, we mean the vertical height and the vertical height here. You add them together, you must get the green color height here, 40 degrees. Okay, my vertical line not so straight. I think it's quite clear from the graph that it's not equal, right? Correct. So that means you can't just split up the sign, distribute it piece by piece. And there's a standard formula for us to actually split it up such that we can involve sine 30 or sine 10 or maybe cosine instead. But without further ado, I'll just introduce the formula. I will skip the proof. I'll just give you the result. Is that okay?
Okay.
When we have more time, I will talk about the proof. But for now, no. Here is the formula. Okay, sine A plus minus B equals to sine A cos B plus minus cos A sine B. All right, what does it mean when you have a plus minus? It's actually just a lazy way because I don't want to write so much, but you will get to see this in the formula list. So that's why I'm introducing it, and also the lazy way. It's actually a lazy way of representing these two formulas, the plus version and the minus version. Okay, take a look. I'm just changing the plus to minus here and here. Is it clear?
Okay.
How to use? Okay. Before I teach you how to use, I'm just gonna list down all the formulas you need to know first. The other one is cosine plus minus b. This will be cos A cos B, and opposite. Let me write down first. Cos A cos B, and opposite. So minus plus sine A sine B. What's this? What's this weird minus plus sign and a plus minus? It means a lazy way of writing down two different formulas. One plus, one minus, the other one minus. Okay, plus minus and minus plus. Okay, basically plus on the left, minus on the right, minus on the left, plus on the right. So I hope you can agree that the cosine formula looks a slightly more complicated, right? Because the
Okay.
sign changes, the sign changes. All of them are complicated, yes, at the start, but the one that is more complicated is this guy. Tricky, because change sign. Sign as in SIGN, not the SIN. Yeah. Okay.
Mhm.
Can. Next, the third formula you must know is tangent A. It's all provided in the formula list. You just need to know when to use which one. Tangent A plus minus B equals to tangent A plus minus tangent B all over 1 minus tan A tan B. Now, minus plus tan A tan B. I hope you know what the plus minus and minus plus means now. It's just a lazy way of writing down. Let's say that I start with a plus here. Then what is the sign over here? What should it be?
Should
Plus or
be
minus?
plus.
Plus, because it follows the same symbol, right? Plus, minus, plus, minus. Then this one, upside down and minus, plus. So this one should be
Minus.
minus. Okay, very good. You know how to read it now. Then if I just change it to tangent A minus, tangent A minus B instead.
Minus plus.
If it's minus here, then it becomes minus plus. Very good. Okay, so that is the three formulas you need to know. Yeah, it's just three formulas. I expanded it out. Oh, I expanded out. That's why you have so many lines. But essentially, it's just this guy, this guy, and this guy. Okay, that's compound angle formula. Let's use it to solve some questions now. Okay, how can I? Yes, I can just copy this diagram. Right? I'll paste it over here so you can have a reference. Now, let's go through an example, how to use this. You want to solve for all the angles in between 0 to 360 degrees of the following equation. Phi times sine x plus 60 degrees equals to cosine x minus 30 degrees. Okay, how do you do that? Wow, so complicated. Got a plus something, got a minus something. I never teach you how to deal with it. So I only teach you how to do sine x, cosine x, tangent x, take the tangent inverse to find, take the whatever inverse to find the alpha. Right? So what do we need to do now is to use the formula. Can you see that this sine x plus 60, you can use the formula over here. The first one. This guy.
Okay.
Right? So how would you expand it? It will be phi open bracket sine A cos B. So sine x cosine 60 plus or minus plus. Then cos A sine B cosine x sine 60. Close the bracket. Okay, then cosine x minus 30 what would it be? Cos A cos B plus sine A sine B. Cos A cos B plus sine x sine. Let me just shrink this down a bit. I need more space. Sine, what is it? 30. Clear? I hope you're not confused. Clear so far?
Okay.
Can using the formula and just using the formula, right? You got minus, then you expand out. It will become the same as this. Oh yeah, just to convince you that it's true. Let's just try with a quick example. Let's say it's cosine of 47 degrees. You can split out as cosine of 40 degrees plus 7 degrees. Using the formula, it tells me it's cos A cos B, then minus sine A sine B. Can you quickly type this in the calculator and convince yourself they are the same? Type in cosine 47 degrees. You will get the 0.68199.
Yeah.
Okay, then you key in this entire line now. Cosine 40 times cosine 7 minus sine 40 times sine 7. Convince yourself they are the same.
Okay.
Done already? Sure.
Yeah, 0.68.
One something. I also don't know all the decimals, but basically they are the same lah. Huh? Okay. Can yeah. Why is it true? Explain another day. Now, how about the 5 here outside of the bracket? You need to multiply in. So what you realize is you end up with, I'm gonna purposely bring the cosine 60 in front, then times sine x, and then the 5 sine 60 degrees here, then cosine x equals to here. I'll just leave it as it is. If you're faster, you can even do the following. You can jump straight to this next line I'm about to do. I remember, oh yeah, sine 60, cosine 60, 30, cosine, sine 30, cosine 30. There are special formulas for it, right? Remember the table over here? And the two triangles? Remember? 30, 45, 60 degrees.
Yeah.
So you can get an exact value. That's exactly what we're going to do now. I'm just going to replace it with the exact values. Cosine 60 is really just the same as sine 30 degrees, so it's half. So it's 5/2 times sine x. Okay. Then plus, okay, let's see. Actually, you know what? Maybe I will just keep it as a half. Don't combine with a 5. 5 times half times sine x. Then plus, here sine 60 is actually √3/2. So 5 times √3/2 times cosine x. It's optional to put the times sign here. Then cosine 30 is sine 60, which is √3/2. And then I multiply by cosine x. I can always swap it around because it's just multiplication. Then I add on sine x, sine 30. Sine 30 is what? Half. Half. So sine x. Notice something common. Denominators, they are all 2. So what can we do? Times 2 times 2. This simplifies it into 5 sine x plus 5√3 cosine x equals √3 cosine x plus sine x. Is that okay? Very good. Yes, so now we can combine the sines all to one side, cosine all to other side. Let's see what will happen. So here we got 5 copy sine, 1 copy sine, bring together, become 5 sine minus 1 sine. The other guy, √3 cosine minus 5 √3 cosine. Altogether, it becomes 4 sine x equals to √3 minus 5 √3. That's 1 copy of √3 minus 5 copies of √3. So that's negative 4 copies of √3 cosine x. Hey, you got sine, you got cosine. What do?
Bring over.
Over, you get tangent. I'll skip a step. Is that okay? Okay, sine over cosine is tangent. And then the negative 4 √3 on top, 4 below. 4 cancels away, left with negative √3. Then you realize you can find your alpha. Again, it's an exact value. This is just 60 degrees. Right? 60 degrees? No? And then because ASTC, this is negative, right? So where is negative? Here and here. So therefore, your x must be 180 minus the alpha 60 degrees, or it will be 360 minus alpha.
300.
And yeah, I didn't write down, but the angle I'm looking for is in between 0 to 360. Okay, I'll just write it at the top. 0 less than equal x less than equal 360. And then we are done. Okay, so we now can solve a larger class of trigo functions when the argument inside, we call the argument, the angle that's surrounding the sine x, or more specifically, this is a function f, and inside there's an x. When the x changes to x plus 60 or x minus 60 or some other angle, we are still able to solve trigo equations involving that because of the formula. Okay, good. That is how you use that identity. And then, of course, there are other examples. Should I give more examples or should I move on to other identities already? Okay, you know what? I'll talk about the other identities already. I don't want to give more examples. I'm just gonna jump straight to the other remaining identities over here. The double angle identities. Okay? Okay, let's go. So now I'll start a new page. we're going to talk about the double angle identity. So in the double angle identity, sorry, it's basically making use of the compound angle identities, but we replace the B with A so that we can get 2A. Did you catch that? Yes, no? I don't know.
Okay.
Okay, so basically this line here, if you recall the plus version, okay, I'll just copy and paste the plus version from above. We can simply replace the B with an A. So what happens then? What happens then? What is sine A plus A? Isn't it just sine of 2A? Right? Then what's sine A cos A? What's cos A sine A? They are the same. Two copies of the same thing means you get 2 sine A cos A. Is this clear?
Mm.
They are the same, right? Sine A times cos A and cos A times sine A. The order doesn't matter. It's just a number times number, number times number. You swap the order, they are still the same terms. So there are two copies of the same term. So that's why there's a coefficient 2 here to make it simpler. All right, then that is double angle identity for sine. How about cosine? Cosine is a bit more complicated because here let me just copy and paste the angle the addition identity for cosine instead of the subtraction one. We got the addition guy. If I change the B to an A this time, what do you notice? You end up with cosine A plus A, which is 2A, equals to what? Cos A times cos A. What's a more efficient way to write down cos A times cos A?
Cos square.
A, cos square A. Yeah. Then the other guy is sine square A. So that's your first identity. There are three. There are three. For cosine, it's complicated. Cosine 2A, it's complicated because cos square A minus sine square A is the first one. But there are two more versions. If you see cosine square, I hope you immediately recall the sine square, cos square, sine square plus cos square equal to 1, right?
Yeah.
So here, if we replace the cosine square with 1 minus sine square, what happens?
1 minus 2 sine square.
Correct, it becomes 1 minus 2 sine square here. That's a second identity. But now what if we replace the sine square with 1 minus cos square? This one you have to be careful because there's a minus over here. So let's work it out. Cos square A minus sine square A equals to cos square A minus away bracket 1 minus cos square A. Why do I put bracket? Because in front has a
Minus.
minus sign. So you distribute in the minus, you end up with cos square, A minus 1 plus cos square A, which is actually just 2 cos square A minus 1. And I hope you notice the symmetry over here. The symmetry over here. 1 on the left, 1 on the right. 2 sine, 2 cos square. Yeah, it's sort of swap position and then they change from sine to cosine. Is that okay?
Okay.
So that's the second identity. I call this the second identity. The third one involves, after we're done with sine and cosine, of course it must be, who's the third buddy? Picasso.
10.
Tangent. So we're gonna use the tangent formula of A plus B. So let's copy it down again, but this time replace the B with, replace the B with
A.
A. Okay, very good. So replace the B with A, replace the B with A. And then you will realize you get tangent of how many A's? A plus A?
2 tangent A.
A. 2 tangent A. Correct. The numerator is 2 tangent A all over. Here is 10A times 10A. What's that? Tangent square A. 1 minus tangent square A. So we get another identity. Okay, this one I better not label 1, 2, 3. I should just group them together and say 3 versions. So you need to know. So we are not testing you on memorizing these identities, okay? We're testing you on how to use these identities, when to use which identity, okay? Given complicated formulas. So let's just go through some examples. Let's see. Okay. Wow, it's already 3:56. Oh no. Oh no. Do you have the oh wait, I haven't sent you. Let me find the correct folder. Lesson trigger identities. Wow, not enough time to go through. Oh no, this is bad. Okay, I just sent you a file. It's got one lesson trigger identities.pdf. Can you open up the file?
Mm-hmm.
yeah, we're gonna go through those questions. I only have 8 minutes left. Okay, I have to end by 4:05. Hold on a second. Let me see. Right. This. Okay, let's go through that. So, do you have the formulas copied down somewhere?
Okay.
No. Okay. How should I do this? Maybe I will send you this screenshot first of the formula list. Give me a second. Okay, where's your chat? Here it is. I'm gonna send you the photo. Then you can have a reference of the formula list. And we're gonna do practice questions now. This is question 1. Trigo identities. Oh, I need to resume share. Sorry. Can you see the chat screen? Yes, okay, let's go. So we have a more complicated version of the usual question you've seen. This is 1 plus tangent alpha over 1 minus tangent alpha. They tell you it's equals to 3 plus 2 root 2. And alpha is an acute angle. Now find the exact value of each of the following. What? You need to find tangent alpha? How? Don't worry. You realize that this is just an equation. You can just solve for tangent alpha, right? Just let x equals tangent alpha. Then in that case, we end up with 1 plus x over 1 minus x equals to 3 plus 2 root 2. Cross multiply. You get times 1 minus x. Multiply out. 3 plus 2 root 2 is just a number, so I'm just going to lump it as one entire lump, times 1 times minus x. So you end up with this guy times x. Okay? Clear so far? Now you want to make x all on the left side. There's a plus 1 here, there's a minus here, so you can bring them together. You're left with 1 minus away bracket 3 plus 2 root 2. Bracket x. Sorry, should be consistent, just a straight line x. Okay, that's after bringing that over, then 3 plus 2 root 2 remains. So I'm just going to copy and paste the 3 plus 2 root 2. But you have to bring the plus 1 over here over to the right. So it becomes a minus 1. Is it clear so far? Very good. Okay. Continue, and then finally solving for x, you just have to divide. So the rest is just clean up. I'm sure you know how to continue. Rationalize the denominator. Okay? Homework. And please open up the bracket. Minus 3 minus 2 root 2. Is that okay? Can, that's tangent alpha. We are not solving, and then this equals tangent alpha. We are not solving for alpha, okay? In this question's purpose is for you to not solve for alpha. You are still able to solve the equations. That is part A. Let's move on to part B. Now, part B is asking you to do the following. Find sine of 2 alpha. Is there a formula you recall? 2 sine alpha. Look through the list. I just send you on Telegram. You can look at the list if you want. 2 sine alpha cos alpha, right? Just from the formula list. Yeah? What's so useful about that? Because now that we solve for tangent alpha already, we can draw a triangle. Okay? Maybe I'll clean this up a bit. This one is 2 plus 2 root 2. Do we really need to rationalize it? Okay lah. I think don't need lah. Oh, actually, I realized it's quite simple. You can just factor out a negative here. So it's 2 plus 2 root 2 at the bottom with a negative outside. Then the 2 plus 2 root 2 will cancel away. You're just left with negative 1. Oh, it's just negative 1. Right? So that means that tangent alpha is negative 1. I can just ignore the minus sign. So opposite over adjacent. So it's 1, 1. Then the hypotenuse of 0, 2. Okay? Can? Good. Does it even make sense for tangent alpha to be negative 1 when the alpha is acute? Not really. It should be positive. So I might have made a careless mistake somewhere. Doing too fast already. Right, here minus bring over should be a plus. Sorry. We change it to a plus. Change it to a plus. So this should be 1 plus 3, which is a plus 4. You factor out. Okay, so yeah, it's not that nice after all. Okay, let me just edit this. If I factor out 2, I'm left with 2 bracket 1 plus root 2. This is 2 bracket 1 minus 2, 1 minus root 2. Yeah, then actually it's not that nice. Tangent alpha is 1 plus root 2 over 1 minus root 2. So if I just draw the triangle without cleaning up, I'll just get opposite over adjacent. And then the hypotenuse is this square plus that square. Okay, I'll just do it quickly. 1 square plus root 2 square plus 2 times 1 times root 2 plus the other guy, 1 square plus 2 root 2 square. That's just a 2 plus 2 times 1 times root 2. Oh, sorry, minus 2 times 1 times root 2. This is equals to, let's call this hypotenuse, so h square. If I simplify this, what do I get? 1 plus 2 is 3 plus 2 root 2. This guy is 3 minus 2 root 2. 2 root 2's cancel away, you're left with 6 equals h square. So h is just square root of 6. Is that okay? Can. Then let's just copy down this triangle to the top. From here, we can deduce what is sine alpha and cosine alpha already. Right? So sine alpha is 1 plus root 2 over root 6. Then cosine alpha is 1 minus root 2 over root 6. Opposite over hypotenuse, adjacent over hypotenuse. Then the rest is just clean up. Like you already know your certs, right? So very good. So part C now. Part C, oh no, now it's cosine 4 alpha. What do we do? We only got formulas for 2 alpha. How come got 4?
Make it 2.
Yeah, just make it 2 lah. So you really just have to rewrite it as 2 times of whatever. It can be anything. This for the formula we have can provide you can replace it with anything. In this case, replace it with 2 alpha. So that means we end up with what? Here, the better formula to use would be the one involving sine, which is 1 minus 2 sine square of the single angle. Here, the A is 4 alpha in the formula list. Sorry, 2A is 4 alpha. Then the single A is 2 alpha. So that means over here is 2 alpha. Is it clear how I use the formula? From 4 alpha become 2 alpha. This is a major point of confusion for many students because they cannot identify who is the capital A here. Capital A is the single, capital 2A is the double. So 4 alpha is double, 2 alpha is single. Okay, so now you realize that sine square 2 alpha, that looks familiar. Isn't that just... Okay, sorry, this part is supposed to be obvious, but the familiar part is this guy, sine 2 alpha. We have calculated it before over here, right? From part B. So we can recycle the information and plug it in over here. So I'm just gonna copy and paste this entire thing. You should simplify it first. Don't sub in the more complicated version. And then I'll put a huge square bracket around it, square it, minus 2 in front, multiplied by a minus 2, and then a plus 1 at the front. Then you just clean up, and that will give you your answer. Is that clear? So this is the ultimate question. It combines all the topics together. You need to know your trigo identities. You need to know how to draw this triangle. You need to know your ASTC. You need to know your double angle identities. Okay? Very crazy question. Question 2. Wow, it's already 4:05. Sorry. I have to stop the lesson as I have another one ongoing. You can go and try question 2 and question 3 as homework. Then later on, I'll send you more homework questions on trigo identities. Can?
Okay, can.
Can? Actually, I already, yeah. Can. That's all for today.
Thanks.
Thank you.
Bye.
Bye-bye.